Assalamu alaikum, dear students. This is our lecture 3, in which we will cover the topics in regression. Um, the chapter is 14 in these statistics book. Section 1 is linear equations with one independent variable. For a linear equation, y is equal to beta naught plus beta 1 x. The number beta naught is called the y-intercept and the number beta 1 is called the slope. And combinedly, we call these two as the regression parameters. You can see here that the graph of the equation y is equal to beta naught plus beta 1 slope upwards if beta 1 is positive or beta 1 is greater than 0. It slopes downward when beta 1 is negative or less than 0, and it is horizontal line if beta 1 is equal to 0. The topic 2 is the regression equation. These are some common notations used in regression and correlation, and all these have their defining formula as well as computing formula. The table is given here. For Sxx, we have the defining formula as summation of x minus x bar whole square, while its computing formula is summation of x square minus summation of x square over n. Um, Computing formulas are usually used when we want to calculate its value. It is easier to compute using the computing formula. So regression equation is written as y hat because it tells us the estimated value is equal to beta naught plus beta 1 times x. X is our independent variable. Means that the value of y depends on what is the value of x here. And for both beta 1 and beta 1, we have their own formulas. Like for beta 1, we have sxy over sxx. And beta naught, for beta naught, we have y bar minus beta 1 times x bar. And these two equations give the slope and y-intercept of the regression line respectively. So there are two types of variables in regression equation. One is the response variable, which we observe or measure. Like in the previous slide, we had x, and predictor variable is what? That is used to predict or explain the value of the response variable. So what is the criteria for finding a regression line? Before finding a regression line for a set of data points, draw a scatter plot. If the data points do not appear to be scattered about a line, do not estimate a regression line. So once we have constructed the regression line, we calculate some other parameters like the coefficient of determination. The coefficient of determination, denoted as r square, is the proportion of variation in the observed values of the response variable explained by the regression. So thus its formula is r square is equal to SSR, sum of squared residuals divided by SST, total sum of square. This is an example of a data. And if we have three x values 1 to 3 and three y values 3, 1, and 5. Using the regression equation, we estimated y hat. Then we calculate another column y minus y bar. Then it's the square. Then we calculated the residual, which is y hat minus y bar. Then we take its square, and together we can use these values to calculate SSR and SST. And there is a general regression identity which states that the total sum of squares equals the regression sum of squares SSR plus the error sum of squares SSE. Linear correlation. So what is correlation? Linear correlation. A linear correlation uh, tells us the degree of linear relation between two variables, and its formula is given here. It can be simplified as the covariation between x and y. If we have two variables x and y, then in numerator we can have the covariation between x and y and divided by the standard deviation of variable x and standard deviation of variable y. Uh, Figure A shows that there is perfect positive linear correlation if r value of r, which is the coefficient correlation, is 1. 0.9 value of r 0.9 suggests that there is strong positive correlation between variables x and y. And if this value is negative, then we say that the relation between x and y is negative. And zero point 0.9 is very close to negative 1, so there is a strong negative correlation. And if the value of r is equal to 0, then we say that there is no correlation between x and y. And there is a relation between correlation coefficient and the coefficient of determination, r and r square. That relation is that the coefficient of determination equals the square of the linear correlation coefficient.